All right, good evening and welcome to the Structural Engineers Association of Northern California's Student Scholarship and Excellence in Structural Engineering Awards program. As you guys know, in a typical year, we'd be gathering together in a formal setting, we'd have music and drinks, and we'd be celebrating our profession together. While Zoom doesn't quite facilitate that same networking opportunity, we feel very strongly that these people and these projects deserve recognition and celebration with our peers. In order to provide you with an optimal viewing platform, we recommend that all attendees go to the view option in the upper right corner and select the speaker view option. And please feel free to use the chat feature during the presentation to recognize your peers. I'd like to begin by giving you a little preview into tonight's program. We'll begin with a special update from our SEAONC State President, Ali Sadre. We'll then announce our impressive student scholarship winners, followed by our Excellence in Structural Engineering Awards program. At the conclusion of the awards, there will be a short networking session where you will be invited to attend a breakout room with either our student scholarship winners or our Awards of Excellence winners. Please hang around to the end and use this opportunity to welcome our students and to congratulate your peers on a job well done. Before I hand off the microphone, I'd like to remind you of just a few brief SEAONC updates. We continue to host relevant technical programs, including a two-part short course on vibration that begins this week. And we continue to host our social events, including our Past Presidents Engineering Interaction Social Hour with Kelly Cobean and John Killand, hosting a SEAONC History Trivia Night on May 20th. And on June 1st, please plan to join us. We'll be holding our annual business meeting, our transition of our board of directors, and our annual awards or annual honors program. I'd like to finish up here with a huge thank you to board members Anna Dix and Katie Briggs and the SEAONC office for running this fabulous Excellence in Structural Engineering program and curating tonight's event. I'd now like to introduce your Structural Engineers Association of California President, Ali Sadre, to provide some brief updates from SEAONC.
Good afternoon. Thank you, Emily, for inviting me. I want to welcome you all to the annual EISC award ceremony of SEAONC. This is a joyous occasion for me as we've come together to celebrate this wonderful event. It goes without saying that the award ceremony is amongst the most treasured occasions of SEAONC. It provides us with an opportunity to reflect on the preceding year and share the achievements of our members. On this important occasion, it gives us a chance to publicly celebrate your success through sheer hard work and perseverance. Awards are a way to encourage excellence in design and execution and inspiration and inspires competition. This is the reason why SEAONC organizes an award ceremony every year. So we're here to give away prizes in different categories, and I'm very pleased to see that our members are performing and excelling in their respective areas of interest. SEAONC has continually received accolades from the profession as well as other organizations, both nationally and internationally. This certainly would not have been possible without our talented members, our committed volunteers, and our executive office. To the wives, husbands, families, and colleagues, I express my deepest gratitude to your encouragement and collective efforts. Whatever our members have achieved would not have been possible without your continued support. Also, I would like to address those who have not won a prize and say, do not despair. This is not the end. There will be other opportunities coming your way to prove your mettle. Finally, to our young members and students, succeeding in this endeavor is as simple as being a great engineer. All you have to do is pay attention, work hard, and give it your best shot. I hope you all have a great time, and thank you.
Thank you so much, Ali. And with that, I'd like to now introduce my friend and SEAONC past president, Janelle Maffei. As past president, Janelle gets to run our student scholarship program, and tonight we're thrilled to welcome our winners to the event.
Thank you, Emily. And being chair or being on the scholarship committee is just an amazing opportunity. And it's really thrilling to be able to announce the winners tonight. And I wanted to say at the outset that in large part due to the generosity of Computers and Structures, we have 7 outstanding students who will be receiving a CSI SEAONC scholarship. And so moving to the next slide, show you the photos of these amazing, amazing students. I'm not able to completely describe the accomplishments of these talented students in the time that we have tonight. So I will tell you just a little bit about each of our recipients. And then unfortunately, in a web meeting, we can't really offer them our congratulations and applause. So we'd really like you to join us at the end of the meeting in the break rooms, where you'll have an opportunity to congratulate both our scholarship and excellent award recipients. So let me tell you a little bit about these wonderful students. Jeffrey Chang is graduating with a Bachelor of Science in Civil Engineering from UC Berkeley this month, and he has been accepted into master's degree programs at Berkeley, Stanford, and UCLA. In his application, Jeffrey mentioned that although I'm still considering which program to enter, I am currently leaning towards UC Berkeley's Structural Engineering, Mechanics, and Materials program. And of course, as a Cal grad, I had to sneak that one in there, Jeffrey. He says that while he enjoys the research aspects of academia, he is currently leaning towards working in industry after his master's degree, as he believes that working as a structural engineer is one of the best ways to apply himself to making an impact on people and the environment. Jeffrey enjoys structural engineering because of its necessity in society. He believes that structural engineering is quite truly the background of society in building homes, transportation, infrastructure, and workplaces. Congratulations, Jeffrey. Kalina Kuneva will graduate from California Polytechnic State University, San Luis Obispo this month. Her focus has been structural engineering, and she will be staying on another year at Cal Poly to get her master's degree with an anticipated graduation from her master's program in spring of 2022. A major interest to Kalina is the use of recycled materials for structural applications. She began to explore this topic by assisting Dr. Long Wang in his research with fabrication techniques to use recycled waste charcoal particles in conductive nanocomposites to act as strain sensors for structural health monitoring. Kalina's career goals include developing innovative ways sustainability can be incorporated into structural designs. Her professional goals are to become a licensed civil engineer and rise to a principal role at a design firm somewhere on the West Coast. And we certainly welcome you and congratulate you. Zachary Morrison is a student at San Francisco State University, completing his final semester of undergraduate studies in civil engineering in the State Scholar Program. He will be graduating with a bachelor's degree in May and plans on continuing his education through the graduate program at SFSU. The San Francisco State Scholar Program gave Zachary the opportunity to take graduate level engineering courses while still an undergraduate and start research for his master's thesis. His research with Dr. Chen was on evaluating modal pushover analysis to solve for estimating seismic demands. Zachary also was involved in improving his community by volunteering to pick up trash with the Surfrider Foundation and Tau Beta Pi and preparing and serving meals at the local community kitchen. Congratulations, Zachary. Sarah Navias is currently a senior at Cal Poly studying architectural engineering. She's excited to be staying at Cal Poly next year to pursue a master's degree in architectural engineering with an expected graduation date of 2020. This past winter, Sarah was nominated for the Architectural Engineering Department for Cal Poly's Outstanding Woman in Engineering Award. During her first quarter at Cal Poly, she joined the Malawi project team of the Cal Poly chapter of Engineers Without Borders. And in the winter of 2019, she was elected by her project team to be one of the cultural education and communications sub-team leads. During her year as lead, she worked with other sub-team leads to create informative content for presentations about their development work and community partnership. During the summer of 2019, Sarah studied abroad in Lithuania, where she collaborated academically with students from Cal Poly and Vilnius Gediminas Technical University in 3 architectural engineering classes. Congratulations, Sarah. Victor Romo intends to stay in San Jose or go to San Francisco for graduate school. His structural engineering interests include seismic retrofit of buildings and bridge engineering. During his undergraduate career, he has had the opportunity to have 2 internship experiences. The first internship was at Granite Rock, a construction materials company where he quickly realized the best way to learn is to ask questions and to listen to the contractors that have more construction experience than he has been alive. And I congratulate you for that. His second internship at HMH Civil Engineers in San Jose, where he learned that school and the real world are vastly different. Having dedicated so much time to the Steel Bridge team in college, Victor wants to utilize those skills by helping preserve the bridges in the Bay Area and by being part of the nonprofit Bridges to Prosperity. He believes structural engineers can be powerfully impactful by improving infrastructure for those that need it most. And a very, very large welcome and congratulations to you. Emily Wong is currently a senior undergraduate student in the Civil and Environmental Engineering Department at the University of California, Berkeley. She intends to pursue a master's degree in civil engineering with an emphasis in structural engineering, mechanics, and materials. At the time of the scholarship application, she was waiting to hear from her first choice, the University of California, Berkeley. While an undergraduate, Emily completed 2 internships within the construction industry at Rodan Builders in 2018 and Pankow Builders in 2019 in preparation for a career as a structural engineer. Emily believes that supporting other students from low-income backgrounds is crucial. So during fall 2020, she decided to become a tutor for the Center for Access to Engineering Excellence, where she helped other students with courses she had already completed. She also decided to mentor 2 freshman civil engineering girls for the first generation mentorship program at Berkeley. I lost my cursor here, sorry about that. Congratulations, Emily. Claudia Zapata Kraft is a senior in the Archie program at Cal Poly SLO, wrapping her undergraduate studies this spring and starting her graduate degree in the fall of 2021. Giving back to her community is one of Claudia's main goals and motivators. Growing up in the Sacramento area, she became accustomed to see many issues with the state and city infrastructure. Consequently, she wants to be involved in improving low-income housing, especially in Northern California. Claudia's incredible experience at Cal Poly is why she chose to continue in San Luis Obispo for her master's degree. She truly believes that furthering her education at Cal Poly will allow her to reach her goals of serving others through her profession. This was an amazing group of students, and I think, as you heard, in addition to their academic excellence, these are people with innately altruist goals and activities that show that they will be a wonderful, wonderful attribute both in their graduate programs and then as they move into the structural engineering profession. So once again, I would really like you to stick around for our breakout groups at the end so that you have an opportunity to personally congratulate these amazing student scholarship recipients. And now, after a huge thank you and congratulations to all the students, it is my great privilege to introduce CSI President Ashraf Habibullah. Ashraf?
Let me see here if I can get this video on. There we are. Hi, everybody. You know, it's, I finally got to pull out one of my jackets. You know, it's been like this whole year with no events, no performances, but I'm so happy that I get this chance to celebrate with every one of you. You know, it's, first of all, I want to start out by congratulating each and every one of you. You know, I mean, you are the future leaders of our profession, and I just look forward to seeing and meeting every one of you in person. I mean, those that know me know how incredibly passionate I am about our profession. But the biggest thing that I like the best is my chance to meet young students and young professionals. And every time I run into you, whether it's on a campus or at a convention or even at one of our parties, just the enthusiasm, the energy, and the excitement that you bring to my life, it's just makes it all worthwhile. And of course, you know, I mean, most of the engineers that are my age that work with me, you know, I graduated 50 years ago. So they're already retired. So it's just, obviously I have to go around looking for, younger people, because I plan to be around another 50 years. So, but anyway, and I just have to say one thing is that I know that every time we get involved with scholarships, having this partnership with the association is amazing, and I get all this credit for doing this, but there's a short story behind this. I remember years ago when I really had no money, I needed $500 to graduate. So after scrounging around, it was bad times, the economy was really bad. I finally got one professor to give me a $500 check and as a loan. And he came to me, he said, no, you don't have to, this is not a loan, you can have the money. But I know a time will come when you will pass this on to others many times over. So every time I write a check to the Structural Engineers Association for scholarship, especially, his voice rings in me. And to me, he said, and I look at it and I remember the words that he said. And to me, that time that he talked about is now, and the recipients that he talked about are you. So you owe me nothing. This is something that I'm passing down for something that I received at a time when I needed the $500 the most. So congratulations, and I really hope to meet every one of you in person very soon. Thank you.
Ashraf, this is Janelle again, and I just want to thank you. And you're absolutely right. Jeffrey, Kalina, Zachary, Sarah, Victor, Emily, Claudia, congratulations. We wish you the very best in your graduate pursuits. And you've already shown us that you're people who want to give back, and we welcome you into our profession. We wish you the very best. And it is now my pleasure to turn over to another brilliant group. Katie Briggs will be introducing the Excellence in Structural Engineering Awards. So thank you, Ashraf, and Katie, back to you.
Great, thank you, Janelle. Thank you, scholarship winners and Ashraf. So this year, SEAONC was thrilled to receive 17 project entries for the 2021 Excellence in Structural Engineering Awards. All of the entries were amazing contributions to our profession and to the public at large. As a reminder, for each of the 6 categories, the jurors can award up to 2 awards of merit for small projects, 2 awards of merit for large projects, and 1 award of excellence for a small project, and 1 award of excellence for a large project. And then they can also award 1 project of the year. All entries that receive an award of excellence or project of the year will move on to the state level Excellence in Structural Engineering Award competition. Today we'll be presenting all award of merit and award of excellence winners in order of category, and a representative from each award of excellence winning company has been invited to speak to accept their award. So the jury, we would like to say thank you to our Excellence in Structural Engineering Awards jury. Lisa Cassidy of HOK and David Kane of Harold Kane Structural Engineers were our 2 structural jurors. Christy Davis of Trubeck Construction was our general contractor juror. Jerome Tobias of ArcFlux Studio was the architect juror, and Jenna Wong of San Francisco State University was our juror from academia. Anna Dix, board member, and myself were the moderators for this year's awards. As previously mentioned, we received 17 entries for this year's Excellence in Structural Engineering Awards. At least 1 project was submitted in each of the 6 categories, and those categories are research, special use structures, infrastructure, historic preservation, retrofit/alterations, and new construction. So now on with the awards. The award of merit in the category of research goes to PEER and the California Earthquake Authority for their project, quantifying the performance of cripple walls and sill anchorage in single-family wood-frame buildings. The overall objective of the peer CEA project was to provide scientifically based information, that is testing, analysis, and resulting loss models, that measure and assess the effectiveness of seismic retrofit to reduce the risk of damage and associated repair costs of wood frame houses with cripple wall and sill anchorage deficiencies, as well as retrofitted conditions that address those deficiencies. Detailed index building information included variants such as the number of stories, 1 versus 2, the age of construction, interior wall and ceiling materials, exterior cladding materials, and the height of the cripple walls. Houses were evaluated using seismic hazard information and ground motions for San Francisco, Bakersfield, Northridge, and San Bernardino, which were chosen to represent the range of seismicity conditions and retrofit design classifications outlined in the FEMA P1100 guidelines for seismic retrofit. 33 experimental tests of full-scale cripple wall assemblies with different construction materials for unretrofitted and retrofitted conditions outlined in FEMA P1100 were conducted. The purpose of the testing was to validate analytical modeling. Over 3.8 million simulations of damage and loss were executed on a high-performance computer cluster, representing 128 combinations of building heights, siding types, exterior and interior wall materials, and nearly 100,000 dynamic structural nonlinear response time history analyses. The loss curves for the houses demonstrate the effect of seismic retrofit by comparing losses in the unretrofitted and retrofitted condition across a range of seismic intensities. The earthquake damage and economic losses were evaluated using the FEMA P58 methodology, which is based on the peer performance-based engineering framework, which incorporates detailed building information and analyses to characterize the seismic hazard, structural response, earthquake damage, and repair/retrofit costs. The project team was composed of academic researchers and engineering practitioners encompassing a broad range of expertise required for the project. 2 peer review panels provided periodic input and feedback during the project. Detailed work was conducted by 7 working groups, each addressing a particular area of study and knowledge and collaborating with the other working groups on a regular basis. A summary brochure targeted to homeowners and non-engineers provides information about reduced repair costs for retrofitted homes. The goal is to decrease losses and increase post-earthquake occupancy. The experimental testing data with different damage states and the body of analytical modeling and loss calculations provides the most comprehensive information to date. And the jurors for our jury was impressed with the amount of coordination required for this project because of all the contributors and the number of working groups. They also felt this project was innovative in its use of high-power computing to go through so many analyses and process so much data. And with the end product being a brochure for homeowners and non-engineers, this project promotes retrofitting of single-family homes, which is beneficial to the public. Congratulations to PEER, California Earthquake Authority, and to all who contributed.
The award of merit in the category Special Use Structures goes to Daedalus Structural Engineering for their project Microcosmic. Microcosmic was the first of 10 public arts projects to be installed for San Francisco's new Central Subway. This art piece by Bay Area artist Moto Otake features a wind-driven stainless steel kinetic sculpture perched at the top of a towering marquee pole at the new 4th and Brannan Muni Station. The sculpture is composed of 51 different pieces spinning around 31 pivoting bearing points. The complex 3-dimensional motion of these components generates a 15-foot diameter steel galaxy of infinitely unique orbital patterns. The structure had to be carefully designed and fabricated to assure the motion is unaffected by welding heat distortion, connection hardware, fabrication technique, and erection. Connection details employed a combination of welding, tapped threaded connectors, set screws, and sleeved connections. A notable challenge that the design team overcame was the low weld stress limits for fatigue design as required for dynamic motion. The juror said, a lot of thought went into building this sculpture with regards to simplicity of connections and making the different components easily replaceable. Congratulations, Daedalus Structural Engineering. The award of excellence in the category infrastructure goes to HOK for their project Salt Lake City International Airport Terminal Redevelopment Program and North Concourse. The new Salt Lake City International Airport is the culmination of nearly 2 decades of planning, design, and construction. The new airport is a small city consisting of a terminal, 2 linear concourses, a gateway center, 2 pedestrian bridges, a local light rail connection, a central utility plant, a parking garage, rental car facilities, 2 tunnels, an elevated roadway, and new airfield aprons. Phase 1 opened in the fall of 2020 with 4 million square feet of facilities. The airport is expected to serve more than 34 million passengers annually. The main challenges the team faced were the airport's massive size, proximity to a strong fall, liquefiable soils, high water table, immediate occupancy requirements, and a LEED Gold target. To meet some of these challenges, the concourse, terminal, and parking garage are structurally designed as 27 seismically separate buildings. The foundation required stone columns and 3,200 composite pipe piles to mitigate the liquefiable soil. The jurors said, the brace frame interactions with expansion joints is interesting, structurally difficult, and would have required a lot of coordination in the field. This project scored high in almost all categories. And here to accept the award for HOK is Lisa Cassidy.
So I have to promise that as a jury member, I did abstain from voting on this project, just for the record. And yes, we were the only entrant in the category, but I'm just still going to accept the award and be happy about it. Anyway, I would call this the Endurance Award, the Blood, Sweat, and Tears Award. It's been 8 years, almost 8 years already, and still going. There are only 2 phases open. There are still 2 more to come. Just as a fun point, it's been 1,200 hours of billable work for me so far, which, if you think about, is 5 3/4 years of work. So it's been a fun one. Every challenge you could get on the project we've had, they added components after the buildings were erected. You know, who needs to have a sterile corridor? Or, oh wait, we should add that later, maybe after the building's up. We also went through a 5.7 magnitude earthquake in March of 2020, so 6 months before the building was open, which was and it had, you know, hundreds of aftershocks, which was a good proving of the stability of the structure. Everyone was really happy. There was damage to the existing buildings, but none to ours, which was great. I can't say enough that the team was huge. We joke that every person in HOK San Francisco has touched this project. Probably, you know, every office in of HOK United States has had someone work on this project. It's been a great team. We had local support in Utah with Dunn Associates and Reevely Engineers, and then Sideplate and Core Brace were amazing partners on the project. So thank you to them for all their help, and some of their elements are very featured on the project. So thank you to that. And yeah, big project. Can't say it's behind us yet, but it's been a lifetime, I would say, project for me, and amazing to work on. So thank you to SEAONC for recognizing us.
Thank you, Lisa, and congratulations, HOK.
All right, the Award of Merit in the category of Historic Preservation goes to ZFA Structural Engineers for their historic Gordon Building project. The iconic Gordon Building in downtown Napa, California, is known to locals as having been home to popular retailers, offices, and other uses for nearly a century. With its Spanish colonial revival style elements, including terracotta siding and ornate floral details, this 1929 structure constructed of steel, wood, brick, and stone landed a spot on the National Register of Historic Places in 1985. Unfortunately, when the 2014 Napa earthquake struck on August 24th, the building suffered severe damage and was deemed a threat to public safety. A post-earthquake damage assessment confirmed what was suspected to have occurred: extreme damage to the structural system, which could have resulted in a teardown. Major structural repairs and a complete seismic retrofit would be required to achieve life safety, and preserving and limiting disruption to fragile historic elements would be a top priority. Integration of a new lateral force resisting system into a two-story historic building comprised of handmade terracotta brick at the street fronts and decorative colonial style architecture features at the interior was one of the many challenges. Beyond the obvious need to strengthen the existing wood diaphragms and out-of-plane wall anchorage, the building lacked an adequate cohesive lateral system. Post-earthquake 3D imaging, when compared to pre-earthquake imaging, confirmed the torsional irregularity of the building via observation of an inch of permanent displacement in rotation about its center axis. While the east wall of the building consisted of a 24-inch thick solid stone wall on the property line, the remainder of the exterior walls consisted of highly perforated brick and terracotta walls that offered little lateral resistance. Steel brace frames were the initial system of choice for retrofit due to their stiffness. However, historic and owner guidelines necessitated an alternate system at the street fronts. Leasing requirements from the current ownership were strict regarding sightlines through the storefronts. Moment frames appeared to be the system of choice to meet both historic and owner requirements in these locations. However, ordinary pin-based steel moment frames had been proven to perform poorly in other retrofitted historic downtown buildings. Although concrete shear walls were also considered, the design team concluded that fixed-base special steel moment frames would be the system most suited for the application. This left the street-side spaces visually open for tenants and minimized conflicts with historic materials. But it also required tight drift tolerances to ensure compatibility with the existing structure, which meant using heavy steel columns and massive anchorage into concrete grade beams. The original Gordon building consisted of a riveted steel skeleton structure supporting the gravity loads from the wood frame, roof, and floors. The design of the new steel frames and collector elements had to be woven in and around the existing framing systems. Installation needed to occur through targeted openings in the roof and floors while limiting the need for disassembly of the existing framing or costly shoring of the roof and second floor. A grand reopening was held February 26, 2020, and the Gordon building remains an integral part of downtown Napa, newly remodeled with its historic elements preserved. The jurors noted how challenging it was to retrofit this building while not disturbing the original architecture. They also liked that such an important building to the city of Napa was preserved despite having suffered so much damage during the 2014 earthquake. Congratulations to ZFA structural engineers. Oh, okay. The award of merit in the category of retrofit and alterations goes to Degenkolb for their high-rise seismic retrofit project. The owner of a 23-story steel moment frame building from the 1970s was considering voluntarily improving its seismic performance. And the owner and the address, the owner prefers the address to remain anonymous. So after considering several retrofit options, the owner selected one that upgraded the welded beam to column connections on the perimeter frames and installed viscous dampers in the corner bays for most of the height. This kind of work is somewhat common for the retrofit of tall steel frame buildings. To address the client's main goal to minimize tenant disruption, the retrofit work was limited to the perimeter of the building. Devising a perimeter scheme was not simple. However, the space between the column and beam center line and the cladding interior limited the size damper that could be installed and required all connection modification to occur from the interior side because cladding removal was not acceptable. Degenkolb worked with the general contractor and steel subcontractor to devise a retrofit approach to strengthen the connections from one side by cutting windows into the beam web to allow the top and bottom flange welding removal and replacement to occur, and to provide alternate supports to allow notching of the existing precast strongback columns to accommodate the dampers. Limiting the retrofit locations helped control costs and minimize the post-retrofit disruption to the building's tenants. What made the project most unique was the innovative permit phasing approach. The project initially kicked off with a typical bottom-up approach, with phase 1 being floors 1, 2, and 3. As phase 1 was approaching completion, the owner asked Dagan-Kolb if the next phase of the retrofit could occur on 3 non-sequential floors in the middle of the building instead of on floors 4, 5, and 6. This would leave 1/5 of the building unretrofit between phase 1 and the starting floor of phase 2. Dagan-Kolb performed advanced analysis on the existing building, the phase 1 retrofit, and the building with the out-of-sequence floor retrofit. Using the intention of the voluntary lateral force resisting system alteration provisions in the California existing building code, Dagan-Kolb proposed a method to compare the out-of-sequence phase with the previous phase and the existing building to show that retrofitting floors non-sequentially did not reduce the overall building seismic performance or create any new irregularities. The design review team agreed with the approach and the assessment that the second phase would not adversely impact the building, but instead improve the performance of the building. Another challenge arose with the third phase. The owner initially requested more floors in the middle and upper portion of the building be the third phase. During analysis, Dagan-Kolb identified some potential issues with increased local demands in the bank of unretrofit floors between phase 1 and 2 and the proposed phase 3. Experimenting with different configurations to address this, Dagan-Kolb identified a solution that installed retrofit measures on one floor of the middle of the block of unretrofit floors. Adding dampers at this level interrupted the response of the unretrofit 5-story block enough to keep the local deformations of the unretrofit floors within acceptable limits. This strategy, designing a retrofit that can be constructed in a non-sequential manner and permitted as discrete phases, represents a huge opportunity to provide flexibility to retrofit high-rise buildings by minimizing the forced displacement of existing tenants. The jurors felt that this project was initially interesting because of the challenge to keep the building operational during construction, but became really impressed when it was revealed that the retrofit was installed in a staggered manner. This project received high scores for integration, complexity, and constructability. Congratulations to Dagan-Kolb.
The award of excellence in the category retrofit alteration goes to Tipping Structural Engineering for their project 633 Folsom Renovation and Vertical Expansion. Originally developed by the Swig Company in 1966, this 100,000 square foot mid-rise reinforced concrete structure no longer attracted modern tenants desiring a corporate home in downtown San Francisco. The landlord turned to a design team that shared their vision to reimagine and expand the existing structure with a 5-story vertical addition, transforming the building into a Class A office tower. The expansion posed significant challenges for the structural design team. To minimize weight and provide longer span flexible workspaces, the new upper floors were a steel frame with wider spaced columns. The lower level core structure was extended and amended to support the new levels. Carbon fiber reinforced polymer collectors were also used to strengthen the existing floors and connect to the new core walls. This required surgical demolition and reconstruction of the core to extend it into the upper floors. The jurors said, "It's challenging to add such a significant addition with the constraints presented, such as the change in column bays." The judges also loved how structural engineering played a prominent role in the project. This project scored high for creativity, integration, technical innovation. Here to accept the award for tipping is Mark Steyer.
Thank you, Anna. This project started with tipping in 2014. And so this has been a long project that just recently completed. And I'd like to thank first our client, the Swig Company. They have an 80-year history of investment and development. And so they have a long-term focus, and their seismic resilience and long-term value and appreciation of what structural engineers can do to contribute to that was a really important part of this project, and really helped us feel like we were contributing to their goals. I'd like to thank our architectural designers, Gensler. They were wonderful collaborators. They really understood both the constraints and opportunities provided by the existing structure, and really worked with us to achieve on a macro and micro level the right detailing and proportioning to create this vertical expansion. I'd like to thank the contractor, Plant Construction. They're wonderful partners in going through everything related to shoring, logistics, unforeseen conditions, and helping us make the conceptual design and the details a reality, which was not easy, as we uncovered a lot of surprises throughout the process. I'd love to thank our peer reviewer, Maffei Structural Engineering. They really contributed to both the quality of the design. They shared their knowledge freely, and were great collaborators with us on the project. So really just appreciated all their contributions. And of course, I'd love to thank all of our project team at Tipping. A variety of folks worked on this project over the last 7 years. Specifically, I'd like to thank our associate in charge, Gina Beretta, and our senior project engineer, Andrew Jimenez, who were on it for almost the entire project, and really with their care and attention made this a reality. And as I reflect on what it's like to work on a project like this for over 7 years, and I think about the satisfaction that we got from working with a great team and realizing this project, really reflect and remember what it was like when we first sat down with the client, and our founder, Steve Tipping, was there. This is one of the last projects that I remember sitting with him and collaborating on what the big idea was going to be, and working with him and translating one sketch on trace paper into a reality. So it's really gratifying and refreshing to think about all the effort that goes and to remember all the contributions that folks have made to make it a reality. So thank you to SEAONC, and thank you again to the project team, which was wonderful to be a part of.
Thank you, Mark, and congratulations, Tipping Structural Engineering.
I guess this is a bit of a spoiler alert, but we did want to say thank you to the projects submitted in the category of new construction that did not receive awards. It was a very competitive category this year because so many projects were entered. The jurors were awed by all entries and had a difficult deciding which projects to award. But if we move on, our first award for new construction is the Award of Merit for a Small Project. This award goes to Holmes Structures for their Golden Gate Park Tennis Center. Since 1894, Golden Gate Park has welcomed tennis players to its grounds. The Tennis Coalition of San Francisco Recreation and Parks Department, and San Francisco Parks Alliance sought to usher in a new era of inclusive tennis with the Golden Gate Park Tennis Center, GGPTC. Stakeholders envisioned a sustainable public facility, a tennis hub open to all ages and abilities, a place that propels youth development, and a flexible center that supports expanding programming and events. For a fully integrated structural design where structure married architecture, Holmes accommodated a bi-sloping roof and overcame code challenges for an extensive timber cantilever. To facilitate open areas for public programming, Holmes placed shear walls in strategic locations. To help obtain LEED certification, Holmes devised a light solution with exposed steel and board-formed concrete walls mixed among timber framing. Holmes also reduced the concrete's embodied carbon. Additional site work included retaining walls, exterior stairs, and preliminary design of the feature sunken stadium court. To realize the Golden Gate Park Tennis Center, Holmes overcame site constraints. The center tucks into a polygonal shaped lot sitting on former sand dunes. To minimize the adverse effects of liquefiable soils in close proximity to the San Andreas Fault, permeation grouting was utilized with a mat slab foundation. Given the uneven ground, Holmes integrated a bi-sloping roof connecting at different elevations with dramatic cantilevers and full-height glazing overlooking the tennis courts. A hybrid of reinforced concrete and wood-sheathed shear walls resist seismic loads. The architect envisioned an exposed timber cantilever exuding wood's inviting warmth and well-being benefits. However, conventional application of the building code initially blocked this feature. Holmes conducted a semi-rigid diaphragm and response spectrum analysis, and the analysis carved out a pathway in the code to justify a cantilevered steel-framed wood-sheathed diaphragm approved by the Department of Building Inspection. The beam cantilever extends outward 14 feet at a maximum length, and the diaphragm cantilever reaches up to 40 feet. Oh, sorry. The Golden Gate Park Tennis Center activates and anchors San Francisco's tennis community on public land. While humble in size, the structure delivers seismically safe amenities and world-class architecture to diverse occupants of all ages, abilities, and socioeconomic backgrounds. The jurors loved this project because of its impact on the community. They were also excited by the innovation needed to design the cantilevered roof diaphragm. Congratulations again to Holmes Structures. The next award is the Award of Merit for a large project in the category of new construction, and this goes to Arup for their Grand Hyatt Hotel at the San Francisco International Airport. The Grand Hyatt Hotel delivers on its project mission to serve as the gateway to San Francisco. It features 351 guest rooms with 22 suites, grand and junior ballrooms, as well as a host of other luxury amenities. The $230 million project was delivered through a design-build partnership with Webcore Builders, Hornberger and Wurstel Architects, and ED2 International. The architectural vision created a host of structural design challenges that Arup was tasked with solving. The overall geometry of the project was a slender, seismically irregular structure with little opportunity for placing lateral elements. Additionally, the curved and notched geometry of the floor plates required a close attention to diaphragm load paths and associated detailing. The multiple ballrooms required that the southern half of the building transfer out its interior columns at the fourth floor. Arup also worked closely early on in design with sustainability consultants and concrete suppliers, Urban Fabric and Central Concrete, respectively, to set ambitious but attainable cement replacement targets for the various concrete mixes. The lateral system for the hotel consists of 3 special reinforced concrete shear walls, one at each end of the building, with a central coupled concrete core and a concrete flat slab diaphragm. The reinforcing in these cores utilizes high-strength reinforcing, and the design code of the project was ACI 31811, and Arup obtained a code exception via peer review to implement this in the design. This is one of the first uses of high-strength reinforcing in a non-performance-based design lateral system in the San Francisco Bay Area. The coupled core has coupling in both major directions and utilizes a mix of diagonally reinforced coupling beams, conventionally reinforced coupling beams, and deep cap beams. The torsional response of the structure was a significant design challenge that was overcome by tuning the lateral system. The gravity system for the hotel utilizes a 2-way post-tension flat slab system. The effect and logical layout of tendons on a curved floor plate with a varied set of column grids and irregular openings proved to be quite a challenge. Adding to this was the presence of 2 pore strips that transverse the irregular column grid. These pore strips were needed to avoid restraint effects between the 3 building cores, resulting in a more efficient use of PT and predictable behavior of the flat slab system. The Grand Hyatt Hotel at San Francisco International Airport is a fitting complement to a world-class airport that will be a timeless and important building serving as the gateway to San Francisco for decades to come. The jurors noted that Arup provided an elegant structural design despite the challenges of the curved and slender shape, as well as the transfer elements at the ballrooms. They were also impressed by the approval of the high strength reinforcing steel through peer review and the sustainability components of the project. Congratulations again to Arup for their award of merit.
The award of merit in the for large project in the category of new construction goes to Burrell Alcesser Engineers for their project UCSF Wayne and Gladys Valley Center for Vision. UCSF's idea for the Wayne and Gladys Valley Center for Vision was to create an architecturally impactful gateway building for the Mission Bay campus while providing high performance, adaptable systems, and a high level of resilience against natural disasters, all within their budget. The resulting building is a 12-story, 340,000 square foot reinforced concrete structure that houses facilities for diagnosing, treating, and developing innovative therapies for various eye diseases. The project used a design, build, delivery process in combination with lean construction principles to maximize overall project value. The integrated delivery team used performance-based design to assess appropriate criteria, initial costs, functional recovery times, and repair costs. Subsequently, the team developed a structural solution that enhanced the seismic performance of both the structure and the cladding, while offsetting the costs with alternative solutions for other structural components. The jurors said, the building was designed with increased seismic performance, but the challenge was in offsetting the significant costs. They also liked the creative use of concrete cover over a PT slab, which allows for future flexibility in location and anchorage of equipment within the building. Congratulations, Burrell Alcesser Engineers. The award of excellence for a small project in the category of new construction goes to Mar Structural Design for their project Casa Adelante Affordable Housing. Casa Adelante is a seismically resilient 9-story affordable housing project for low-income seniors, with 25% of the units reserved for formerly homeless seniors. The project creates affordable seismic resilience with 0 days of downtime for repair after a major earthquake and a high-performance cost premium of just 0.25%. The high-performance structural design for this reinforced concrete building features self-centering walls on a rocking mat foundation and a state-of-the-art damper within the foundation. The lead extrusion foundation dampers were developed by Professor Jeff Rogers at the University of Canterbury, who was pleased to apply his technology to a real project and for a great cause. Much of the work to develop, review, and produce this new product was pro bono. The jurors said, the structural design team developed a very interesting approach to an economical issue. This building is the first affordable housing project to ever receive USRC Gold rating, and possibly the first high-performance design in the US for low-income occupants. The use of a new type of damper is structurally innovative and contributes to the profession. Here to accept the award for Mar Structural Design is David Marr.
Thanks, Anna. On behalf of the entire team, I want to thank SEAONC, especially the developers, Chinatown Community Development and Meta Mission Economic Development, as well as the San Francisco Mayor's Office Housing. We were really thankful for them greenlighting the performance-based design. I also want to thank the architects, Herman Culliver Locus, and Cahill Construction, the contractors, and give a super big shout out for Jeff Rogers, who developed the damper. He's a professor in Canterbury, and he actually designed and built the whole thing and packed it up and shipped it to us. Again, and as was mentioned, all his work was pro bono. I also want to thank Greg Deerline at Stanford. Greg's work was pro bono. Essentially, what happened is we had a big idea to make resilience affordable, and we wanted to make who were financially vulnerable safer in their homes after an earthquake. And we set aside this goal to do it without spending any extra money. And so I called my friends and said, can you guys, we're doing a little resilience party. Can you help? And they all jumped on board. So I want to really thank them again. Also thank the U.S. Resilience Council, who waived all their fees for the project. So thank you, SEAONC.
Thank you, David, and congratulations, Mar Structural Design. The Award of Excellence for a large project in the category of new construction goes to Skidmore, Owings, and Merrill for their project, Hangzhou GT Land Jumeirah. Hangzhou GT Land Jumeirah is a mixed-use 7-star hotel, retail, residential, and office development located in the emerging central business district of Hangzhou, China. The hotel and office tower is a slender 200-meter tall structure. This new development seeks to explore the forward optimism and rich history of the area. The spirit of Hangzhou's famous West Lake is captured through the attention to scale and multiple textured rippled facades, creating an urban spectacle that is able to convey the building's sense of calm. The project design team overcame challenges associated with mixed-use space being parsed into 3 buildings seismically separated above grade. In addition, the building has extremely adverse geometry, as you can see, with its vertical geometric irregularities, horizontal geometric irregularities, mass irregularities, discontinuous diaphragms, column transfers, coupled structures, reentrant corners, and out-of-plane irregularities. The jurors said, "This project is huge and complex in its geometry and slender profile, requiring special review and approval under Chinese design codes. Beyond the design innovations, the team solved constructability challenges such as using delayed pore strips to address the differential settlement." Here to accept the award for SOM is Neville Matthias.
Thanks, Anna. I don't know if I'm visible or if I have to do something. There we go. Thank you very much for this award. On behalf of the team, who I'd like to acknowledge, first of all, our partner, Mark Sarkeesian in the structural group, as well as my colleagues, John Gordon, Joanna Zhang, Jeffrey Brunn, and Mahmoud Hachem. The team worked on this uniquely challenging and very interesting project together, and our architects who worked with us, senior architects, for our design partner, Michael Duncan, and Director Javier Arizmendi. We also work, as we do on projects like this in China, with a local group and the local design institute, which I would like to very much acknowledge, is the Hanjia design group, and the contractor was China First design group. The main thing that stays with me with this project is, on account of its slender, on the main tower, office hotel tower, on account of its slender proportions and openings, etc., the difficulty in controlling torsion. And so my colleague, Jeffrey Brunn, spent hours and hours doing many, many, many models and became an expert at tuning structures by trying to get the centers of mass and rigidity to align. And so kudos, Jeffrey. Lots of thermal studies too to be done on this project because of its length, about 550 feet long and 78 feet wide with 3 cores. So, we had Mahmoud Hachem do some very intense thermal studies too. Everybody did a wonderful job, and I want to thank them all. And thanks, SEAONC, for this award again. Thank you.
Thank you, Neville. And congratulations again, Skidmore, Owings, and Merrill.
The final project is the Project of the Year Award of Excellence, and that goes to Rutherford and Shakeen for their new construction project, Lawrence Berkeley National Laboratory Integrative Genomics Building. By consolidating 2 U.S. Department of Energy research programs, the Joint Genome Institute and Knowledge Base, into one facility on the Lawrence Berkeley National Laboratory campus, the new Integrative Genomics Building, IGB, supports LBNL's vision of developing science and technology solutions for the world by bringing together multidisciplinary teams of researchers and creating world-class tools for scientific discovery. The project's guiding design goals included promoting synergies and interaction across the facility's research programs and staff, maximizing sustainability, and incorporating the flexibility needed to adapt to future advances in technology and changes in work styles. The 4-floor, 80,880 square foot IGB accommodates approximately 300 occupants and contains wet and dry research laboratories, research offices, workstations, and shared building support. The building sits on the former Beavatron Particle Accelerator site and is adjacent to several other significant research facilities. Distanced approximately 1/4 mile from the Hayward Fault, the building occupies a very high seismic zone and is bordered on 2 sides by steeply sloping hills. The project melds high-performing seismic solutions, state-of-the-art sustainability, and light-filled open office and laboratory space to create a uniquely efficient, functional, and forward-looking research facility that will support future generations of scientific advancement. There were three primary challenges facing the design team when designing the foundations for IGB: very high seismicity, high overturning forces, and densely arranged caissons left on the site from a demolished structure. IGB's site is approximately 1/4 mile from the Hayward Fault. As a result, it has a response spectra that's roughly 25% higher than the standard USGS earthquake requirements, and therefore subject to very high seismicity. Because of the building's massing, the lateral system was concentrated in a series of shear walls subject to very high overturning forces that then subjected the foundation system to very high demands. Furthermore, the project was built over the demolished Beavatron Particle Accelerator building on a site referred to as Beavatron Flats. Though the site was level, the geology was complicated as it is an old cut and fill site created in the 1950s when the original building was built. The sloping layer of bedrock was overlain by relatively soft soil and therefore required a deep foundation system to reach stable rock formations. This was challenging because IGB was located directly above the very dense circular array of bell caissons buried approximately 15 feet underground that had supported the previous building. The caissons were left in place when the building was demolished, and the team did not have clear documentation of their exact location. To address this challenge, RNC worked closely with the geotechnical engineer and arrived at a micropile system that, due to the small diameter of the piles, was capable of installation around and in between the existing caissons. The result was a high-capacity foundation system that could be woven into the ground while avoiding the existing caissons. The IGB had 2 major programs which drove the architecture: laboratory spaces and office space. It was decided that to avoid designing the whole structure to the rigorous vibration requirements needed for the laboratories, the building would be divided into 2 discrete parts by program, with laboratories on the first 2 floors and office space on the floors above. The IGB sits in a curved embankment with the main access road for the loading dock level with the building's 2nd floor. The laboratory space on floors 1 and 2 required high ceilings as well as adequate room above the ceilings for the intense MEP infrastructure. However, the height of the 2nd story was constrained by the need to meet the loading dock ramp. This meant that a steel frame system would not work for these floors, and then a flat slab system was needed. By contrast, the upper floors of the building were offices that had fewer MEP constraints, but needs to be open and flexible. To complicate the matter further, the massing of the upper 2 floors of the structure needed to be responsive to the site and take full advantage of the sweeping views to the west overlooking the San Francisco Bay. To do this, the axis of the upper 2 floors was twisted approximately 15 degrees from the laboratory floors below. This created a significant challenge for the design of the lateral system, as it meant that the only locations where the columns of the upper stories aligned with the lower floors were in the stairwells, elevator shafts, and restrooms. Given the extreme seismicity of the site, the lateral system needed to be continuous between these twisted masses with no offsets. To accomplish this, a concrete shear wall lateral system, which was selectively located in the stair and elevator shafts and restrooms, was provided. These load-bearing shear walls provided a stiff structure with high accelerations and concentrated drag and collector forces. For the structure of the 3rd and 4th floors, RNC opted for a very lightweight system consisting of steel columns only at the exterior grids with long span joists spanning between them. This provided a clear, column-free internal space and had the added advantage of making the stories light enough that the girders supporting them could be of modest depth, simplifying MEP collaboration at this transfer floor. Lastly, the architectural design included cantilevering a portion of the west end of the building where the lower floors were concrete, out beyond the main columns and limiting the number of columns supporting this west facade. The solution was to incorporate post-tension beams to provide the long span systems needed for these cantilevers. The design of the IGB is remarkable in the way it draws inspiration from the constraints imposed upon it by the site and program requirements. Each element is carefully chosen to maximize efficiency and retain the architectural vision of the building. The structural systems used to solve the site and program constraints require the structural team to pull from a wide variety of structural materials, including micropiles for foundations, concrete shear walls for lateral, post-tension concrete beams and girders for the cantilevers, and long-span steel systems in the upper floors. The jurors loved this project. They commented specifically on the variation in layout between the labs located on floors 1 and 2 and the offices on floors 3 and 4, and how that limited the layout of the lateral force-resisting elements. They were impressed by how the design was able to overcome the project location with its proximity to the Hayward Fault and it being an extremely difficult area to build in. The consideration for sustainability in the design and the fact that the foundations were designed around an existing system also received high praise from the jurors. David Blyman from Rutherford and Shakeen will be accepting the award for Project of the Year. Congratulations, David.
Thank you. Well, I really want to say how honored I am by this award and humbled by the level of excellence of the competition, and just want to say what a pleasure it is to be in this profession and to be making contributions to our society as a whole. You know, we've worked at Lawrence Berkeley Labs for over 20 years, and what I love about working up there is just what they do. And so this project is for genomic interpretation of plant life. Their goal is to help feed the world. And so by doing genomic research, they are doing incremental increases in productivity of plants for farmers all across the world. It's a global institute. And so when we do these projects, I feel a great deal of pride in the contribution that we make, not just to the project itself, but to the work that these scientists do. And I'm really just grateful to be a part of this process. And I want to say also that projects are really about people. And so the collaboration and the effort that everyone put into this project really was what made it successful. And so I want to spend a little bit of time just congratulating the people that contributed to this. So at RNC, it was Tanjeet Juneda and Francisco Parisi that worked primarily on the structural design with me. And at Smith Group, it was Suzanne Napier and Roxanne Malik and Lily Lai. And Smith Group always manages to find ways to challenge me, and this project was no exception. At the lab, you know, we had tremendous support from Tim Hart, Dean Sedlacek, and Stan Tahowski, and without their support, this project really would not have been possible. And finally, I can't leave this award without acknowledging the hard work that our contractor did, which was Rudolph and Sletton. And want to thank both Albert Lee, who was the project manager, and John Santiago, who was the superintendent on the job, for doing an excellent job under very difficult conditions. And again, want to thank the SEAONC for this award.
Thank you, David, and congratulations again to Rutherford and Shakeen. Thank you all for joining us for the presentation of these awards. Just a reminder to join SEAONC for the June 1st business meeting. And we will now be opening up 3 breakout rooms, one with our scholarship winners, one with 2 of our Award of Excellence winners, and one with 3 of our Award of Excellence winners. You will randomly be put into a breakout room, but once there, you can request to exit the room if you want to congratulate people in more than one room. We hope to see you in one of those breakout rooms to congratulate our Scholarship and Excellence in Structural Engineering Award winners.